Hello everyone, welcome to DNSQL. I'm Dinesh Priyankara, Data Platform MVP from Sri Lanka. With this video, we are going to have a look on Azure HDInsight, which is one of the Microsoft Azure services. Let me start this showing what I have planned for this video. First, let's try to understand what is Hadoop and what it is for. We need to understand it because HDInsight is based on it. Then we'll talk about HDInsight Cluster. What is HDInsight? Its configuration, cluster types available, and settings we have to know when we create it. I have included two demonstrations, one for showing the way of creating it and another for showing you the way of accessing it. Okay, let's start it. What is Hadoop? If you Google, you will find different definitions, but the meaning is same. Main thing you need to remember is it is an open source programming framework for distributed processing and distributed storage for large data sets. Or we can say it is for big data. This framework runs on cheap community hardware, formed as a cluster. Since they are not expensive or modern hardware, it is economical, but possibility for failure is high. But the framework manages failures with software techniques. Remember, even though the cluster can be set up as a small cluster for processing and storing small datasets, it is mainly designed for large datasets. Let's talk about its configuration. This was inspired by Google File System paper published in 2003. Then in 2005, Yahoo developed this. In order to build this cluster, all you need is two servers. First server will be designated as the name node, and the second server will be designated as the worker node. Sometimes we refer worker node as data node too. Name node is responsible for cluster management. It does not store data, but it knows where the data is stored, and it directs a processing request to the correct worker node. You can have an additional name node for high availability. Worker node stores data and takes care of data processing as per the instruction received from the name node. You can have as many as worker nodes you want for increasing the data processing power and storage. There are three major components related to the framework. One is HDFS, or you can call it as Hadoop Distributed File System, which is the distributed storage layer of Hadoop. It allows us to store data without a schema, and it makes sure that data is durable and we don't lose data. It manages this by splitting files into multiple chunks and distributes those chunks among worker nodes. Let's see this process with another video later. MapReduce is processing framework for HDFS. Processing is done using jobs that mainly have two functionalities, one for mapping and another for reduce. Again, since this video is not specifically about Hadoop, we'll talk about this with another video. Third one, Yarn, yet another resource negotiator. It manages both cluster resources and resource allocation for jobs. Hope you have a good idea on Hadoop now. Let's talk about HDInsight. What is Azure HDInsight? We can simply describe it as Apache Hadoop running on Microsoft Azure. This means Apache Hadoop is available as a cloud service or cloud platform. Therefore, we don't need to spend time on building the cluster. We can pass instruction to Azure explaining the cluster we want, and Azure will create one for us. Let's see how it creates a cluster for us. HDInsight uses configurations of HDP, Hortonworks Data Platform, for creating the cluster. You can see HDP version when you create it. Hortonworks is one of the vendors related to Hadoop who makes changes to the original code and enhance its functionalities. There are some more companies who do the same, example Cloudera and Mapr. Since Microsoft HDInsight is based on HDP, it makes sure that latest Hadoop technologies are available with the cluster we create. HDInsight configures the cluster using multiple virtual machines, just like the way we build Hadoop using multiple servers. It makes sure that all required Hadoop technologies are installed and configured, hence we don't need to worry on installing individual components. Initially, we were able to set the cluster operating system as Windows for running the cluster, but now it is not possible. You will see that option is still available, but the cluster has to be set with Linux for creating it. Remember, we discussed HDFS, which is Hadoop Distributed File System. HDInsight should be configured with either Azure Blob Storage or Azure Data Lake 2 as its storage. Once configured, it behaves as HDFS. When compared with Hadoop, it looks like that the storage is outside the cluster, but when worker nodes need data, it ingests required chunks for completing the MapReduce job. There's a big advantage with this decoupled storage. We can work with the storage using other applications without going through the cluster. We can even drop the cluster without dropping the storage, and if required, we can create it again using the same storage. Hadoop uses MySQL for maintaining its metadata, but HDInsight maintains its metadata using an Azure SQL database. If you want, you can configure one of your Azure SQL instances for this. That allows you to query metadata using standard SQL Server techniques such as TSQL. Not only that, you can retain metadata after you delete the cluster, such as metadata related to Hive tables, and you can reuse them with another cluster whenever you want. There are many different types of clusters available with HDInsight. Let's understand cluster types available. The one we discuss is Apache Hadoop. It is available as a cluster type. It consists of many components and tools such as Hive, Pig, Ambari, and Uzi. The second is Apache Spark, which is mainly for data processing using in-memory technologies. This provides greater performance for producing results. Apache Storm is a distributed real-time complex event processing running on top of Hadoop. It is used for processing streams of data and producing output while it is in flight. This is available as another type. HBase is a table store for NoSQL. If you need to store semi-structured or unstructured data for reading and writing, you can configure HDInsight cluster as HBase. We have another type called Interactive Hive that has only Hive services. This uses in-memory caching for running interactive queries against Hive tables. If you want to use R libraries, you can configure your cluster as Microsoft R Server. If you have a requirement for handling large number of events, billions of events per second, Kafka is the best. It is also available as a cluster type in HDInsight. Remember, Interactive Hive and Kafka are not fully released yet. They are under limited public preview, but you can try and see. Another thing you should remember is you cannot combine these types in a single cluster. If you have a requirement for two different cluster types, you need to create a cluster for each. You can create your cluster using different ways. You can use Azure Portal, you can use Azure PowerShell, or you can use Azure CLI. The good thing with Azure is most of things can be created with few clicks. Same goes for HDInsight too. You can set values for few properties and get the cluster created with default values for other properties. But it is always better to know these properties and set these values accordingly. Let's talk about some of the important settings we should know. Cluster creation starts with setting the name and the subscription. If you have multiple subscriptions, then select the appropriate one for you. When you create the cluster, you need to decide the cluster type. That is what we talked about with the previous slides. For an example, you may select Hadoop as the type if you want to use Hive for processing semi-structured or unstructured data. If you want to handle an IoT scenario, you may use Storm. We had an option for selecting the operating system, but now it is limited to Linux. Fourth one is the version. You will see that multiple versions are available and new versions will be added based on HDP releases. If you are creating a new cluster, it is always recommended to select the latest version. If you are migrating an on-premises Hadoop cluster to HDInsight, then you can select the version as per your existing configuration. Cluster tier. This determines component available, support level, versions, and the price as well. There are two tiers, standard and premium. You may select standard initially and set the nodes as you want. Later, if required, you can change. For premium tier, there is an additional surcharge on top of the standard price. It is always better to create all related components under a single resource group. If you have already created your storage under one resource group, you can use the same for your cluster. You have to mainly create two administrator accounts. One is the default user based on HTTP, another one is for secure shell user. You can set different passwords for these two accounts, but if you want, you can set the same password for both. Azure supports multiple regions. Hence, you can select the region best for your cluster. But remember, you need to make sure that the both cluster and the storage are in the same region. You should set storage for your cluster. As we discussed with previous slides, you can use either Azure Blob Storage or Data Lake Store. If you select Azure Blob Storage, then you have to name the container as well. Optionally, you can add an additional storage that the cluster can access. When you configure the cluster, you need to specify the number of nodes you need as named nodes and worker nodes. The default size for the Hadoop cluster is 2 head nodes and 4 worker nodes. The default setting is different from type to type. Number of nodes configured decides the cost. Remember, you have to pay as long as the cluster exists. Billing starts when you create the cluster, and Azure stops billing you when the cluster is deleted, and it is prorated per minute. Therefore, it is always better to start small, like 1 name node and 1 worker node, and then increase the size as your data grows. Your nodes are virtual machines. There are 2 types of series available for virtual machines. A and D1 to D4 series that are general purpose Linux VMs, and D11 to D14 series that are memory optimized Linux VMs. You can have a look on all available VMs with node pricing tiers blade, analyze the cost, and select the best as per your requirement. If you need some other Hadoop related applications installed in your cluster, you can use Application Blade. It shows all available Microsoft provided applications and third-party provided applications. You can select application required for your cluster and get them installed. You can run additional script during the installation using script actions. It allows you to add scripts for installing additional components or customizing your cluster. Okay, we discussed many things. It is time for seeing the way of creating it. Let's create a Hadoop HDInsight cluster. I have logged into my Azure account using Azure Portal. In order to create a HDInsight cluster, we need a storage. Optionally, we can have our own SQL Server database for Metastore. Let me show you the database I have created for my cluster. You can see that I have created a SQL Server database called HDInsight Demo in DNSQL RG resource group. And I have configured storage too. I have named it as DNSQL AS storage, and it is in a different resource group which is called DNSQL RC. Now let's open HDInsight Cluster Blade. I have already added HDInsight to my favorite section. If you have not added, go for more services and search for HDInsight and add it as your favorite service. Okay, let me click on HDInsight Cluster to get the blade open. I can click on Add to create my cluster. And I'm going to give a name for my cluster as DNSQL HDInsight Demo. Once the name is given, I can select the subscription I want. Next is cluster type. When I click on it, another blade is open and I can use that blade for selecting my cluster type. So in this case, it is Hadoop. Operating system is going to be Linux, and I'll be selecting the latest version, which is Hadoop 2.7.3. Cluster TA is standard, and once everything is selected, I can click on select. Then I need to set the username. I'm going to name the user as Dinesh and set the password. I'm not going to change the SSH user, and I'm going to tell this guy saying use the same password which is set for Dinesh. Next is the resource group. I have to use the same resource group that I use for my storage, in this case DNSQL ASRC. Once the location is set, I can click on Next. Storage blade allows us to set the storage. Since I have already created the storage, I can select my primary storage as Azure Storage and select the storage I have created. Once it is selected, I need to name the container. Since the name has been already given, I'm going to change it as DNSQL HDInsight Demo. We can add additional storage, but I'm not going to add any additional storage for this cluster. We'll set Metastore as our SQL Server database. I'm going to select the database I have already created for Hive Metastore. all I had to do is just pass the credential required for connecting with the SQL Server database and say that this is the database I want to use it for my Hive meta store. I can do the same for Uzi as well. Once everything is done, it shows the summary. Since we did not set the cluster size, you can see the default has been set. If I want to change the default, I can click on Edit and get the cluster size blade open. I can change the number of worker nodes as I want. I can set a smaller number or I can set a higher number. If I click on worker node size, it shows me all recommended virtual machines. If I cannot find the required one for my cluster, I can click View All and see all available virtual machines. I can go through it, I can analyze the rate, I can analyze the configuration and pick the best. Based on my selection, it will calculate the total cost and show me. If it is okay, I can click on Next. For getting advanced settings blade open, if I have to set some advanced settings like script actions, I can set it. Since I don't have anything for this cluster, I can click on Next to see the summary. So if everything is okay, I can click on Create to get my cluster created. Once it is clicked, it starts creating it. Generally, it takes about 10 to 15 minutes for completion the creation part. Once the cluster is created, you can access it using various ways. You can use Azure Management Portal for managing and monitoring your cluster. It uses Ambari web interface and you have to use default user for connecting with it. You can open it either clicking Cluster Dashboard button or using a URL like https://yourclustername.azurehdiinsight.net. You can use remote consoles for connecting and accessing your cluster. It needs SSH user. For an example, if you want to access your cluster using a tool called PuTTY, you have to get the host name and use SSH user and the password for connecting with your cluster. Let's see how we can connect with the cluster using the PuTTY with next demonstration. In addition to that, we can use Azure CLI, Visual Studio, or PowerShell for accessing the cluster. Let me show you the way of accessing the cluster created using Azure Portal and PuTTY. If I open HDInsight Blade, I should see my cluster created. If I click on my cluster, it will open more blades showing various properties related to my cluster. I can see multiple buttons, multiple properties. I can click on Cluster Dashboard for seeing how my cluster doing using Ambari web interface. Or I can click on Scales Cluster for resizing my cluster. In addition to that, I can see other properties such as location, resource group, and subscription. Let me click on Cluster Dashboard for opening Ambari web interface. URL goes as I explained with the previous slide, and I can see high-level snapshot of the cluster performance with two tabs called Metrics and Heat Maps. In addition to that, we have Services view for seeing details related services, and we have Host view for seeing usage of nodes. In order to see Ambari views such as Hive, I can click on Admin View and then click Hive View. It opens Hive View with functionalities related to the view. With this Hive View, I can see tables created, columns related to tables, and DDL statements for tables. In addition to that, I can see storage information of tables too. And I can see many more information related to my Hive objects. I can go to Query tab and write statement against tables in my Hive. I can execute my query and see the result using the same view. If I want, I can get the result copied to my local machine as well. If I want to resize my cluster, I can click on Scales Cluster and change as I want. I can see the cost for my change immediately, and if it is okay, I can save it for resizing my cluster. If I want to access my cluster remotely, example using my local machine, I can use a tool like PuTTY. For that, I need the hostname of my cluster. I can click on SSH in order to get the blade open. I can select the hostname and get the value form as username at hostname copied to my clipboard. Note the first three letters SSH in the value. We should use the copied value without it. Let's try to access the cluster using PuTTY. If you have not installed, go to the shown website and get it downloaded. You can get either MSI or exe and install it in your local machine. Since I have already installed, I can use it without downloading it again. Let me open PuTTY for connecting with my cluster. I can use the copied value for setting the host name. Remember, we have to remove the first three letters. One more thing, I want to see the window with large font for better reading. So I'm going to change the font size using the appearance page. Once everything is done, I can click Open for connecting with my cluster. It needs a password for SSH user. Once the password is submitted and it is correct, PuTTY allows me to work with the header node. Let me check few things. I can explore the cluster using HDFS, DFS with LS switch. That will show me all folders exist in my cluster. If I want, I can go into a folder and see the content. Let me see the example folder. I can go into more folders, example and data folder. If I want, I can read the content of the file. Let me use HDFS, DFS and tail switch for reading one of the files exist in this folder. I can even connect with Hive and execute Hive queries. I can type the command as Hive in order to connect with the Hive. Once connected, I can execute HiveQL statements. For example, I can say show databases to see databases. I can execute a select statement to see the result of one of my tables. Let's have a look on the storage related to cluster. I'm going to use a tool called Microsoft Azure Storage Explorer for seeing the containers. Once I connected with my storage, I can see all containers available and I can click on the container related to my cluster. I can see folders, I can see files, I can copy those files into my local machine or I can upload files into this storage. Since it is a decoupled storage, I can simply work as I want without going through my cluster. I can even drop the cluster without getting my storage dropped. Okay, hope you have learned basic of HDInsight. If you want to see more on HDInsight, please refer this URL for seeing blog post I have made on HDInsight. Let's see more videos on this later, specifically on big data processing with HDInsight. Thanks for watching.